channel. So in this slot, we're going to discuss few revision for the midterm exam starting from chapter 3, chapter 4 and chapter 5 form 4. Alright, in previous video, I already discussed all these chapter 3 questions. So I'll continue with the another important chapter 3 under here. We need to explain the differences between the empirical formula and molecular formula. Please remember the differences between molecular formula and empirical formula. Try to read the question. Given the glucose C6H12O6 is made up of carbon, hydrogen and oxygen element. The molecular formula of glucose is C6H12O6. The molecular formula of one molecule of glucose has 6 carbon atom, 12 hydrogen atom and 6 oxygen atoms. Alright, the simplest ratio will be 1 to 1. So we have carbon 6, hydrogen is 12, oxygen is 6. So divide with 6, divide with 6, divide with 6. So 1 to 1. So the simplest ratio of mole of atoms of element in glucose molecule is 1 to 1, and therefore the empirical formula is CH2. So this is the short essay question. So we move on to the next question. Look at the question given in the module. Alright, so the diagram below shows the two similar balloon filled with 120 cm power 3 of carbon dioxide. So this one 120 cm power 3 of carbon dioxide, and this also 120 cm power 3 of carbon dioxide. We try to convert this one into cubic decimeter, so that will be 120 divided with 1000, so this will be 0.12 dm power 3. This one also 0.12 dm power 3. Alright, when volume is given, volume in dm power 3 given, how to find the number of mole? We take the volume divide with molar volume. Alright, so we try to find the number of mole of carbon dioxide and number of mole of hydrogen. So we try to check the question. So explain why the balloon filled with hydrogen gas float higher when released, although the balloon are filled up with same volume of gas. So we try to find the mass of carbon dioxide and also the mass of hydrogen gas. So how to find? So we try to check. We try to find the number of mole of carbon dioxide. We take volume divide with molar volume. So the volume given, volume of carbon dioxide will be 0.12 divided by 24 will be the molar volume. So the answer 0.005 mole. And next step, we try to find the mass of carbon dioxide, number of mole times with molar mass. So number of mole of carbon dioxide 0.005 mole times with the molar mass of carbon dioxide will be 44, which given in the question. So the mass of carbon dioxide will be 0.22 gram. And same we do for hydrogen. Number of mole of hydrogen, we take the volume 0.12 divide with the molar volume given in the question. Molar volume is 24, so that will be 0.005 mole. And we try to find the mass of hydrogen gas, mass number of mole times with molar mass. So we try to find 0.05 times with the molar mass will be 2, so the answer will be 0.01 gram. Alright, so the mass of carbon dioxide given is 0.22 and the mass of hydrogen is given 0.01 1 gram. So therefore the mass of hydrogen gas is lower than compared to carbon dioxide. So the balloon containing hydrogen gas is very much lighter mass, although the balloon have the same volume. Alright, so next we go for Ahmad asked to determine the empirical formula of oxide of metal Z. Oxide of metal Z, he was supplied with the powder metal Z. So if let's say, so we have metal Z and another one they supply with oxide of metal Z. So in determining empirical formula, if let's say this metal is reactive, we can use the method heating the metal via oxygen gas. So we can use the metal via heating the metal with oxygen, or if let's say the metal is less reactive metal. If the metal is less reactive metal, we can take the metal oxide, we heat it with the dry hydrogen gas. So we can heat the metal oxide of metal, we heat it with dry hydrogen gas. Alright, we try to check the observation given here. Alright, when the metal oxide is heated under stream of hydrogen gas, no observation. That means this method, heating the metal oxide with dry hydrogen method, is not suitable. So therefore we take this method. How to describe? So describe how Ahmad can derive the empirical formula of metal oxide. We take the metal Z react with oxygen to produce oxide of metal Z. So how to describe the experiment? They need to describe the procedure. So the first procedure, clean 10 cm of length of metal M ribbon with sandpaper. Roll the metal Z ribbon to form a loose coil. Wait and record the empty crucible with its leads and place the rolled metal Z in the crucible. Wait and record the mass of crucible with the rolled metal Z. So we try to write down this point at here. Alright, so empty one and this point here. Alright, so next one we need to heat up the metal Z very strongly without lid. Close the lid when the metal Z is completely burned. Alright, so next point, metal Z is when the metal Z is completely burned, we waited and record the final mass of crucible and its content, and we record this point here. Alright, so then the last point, repeat the process of heating, cooling and weighing until a constant mass of oxide of metal Z is obtained. And how to find the result, how to do the result? So in description we do table mass of empty crucible plus lid. So we put here mass of empty crucible, lid and metal Z, and the final the mass of crucible, lid and metal oxide. So that's how we answer the experiment. So we move on to the next part under predict table of the element. So in the predict table of elements, so please remember the development of predict table under Dmitry Mendeleev. The arrangement, the points that student must remember: Dmitry Mendeleev arranged the element according to increasing order of relative atomic mass. So must remember this one, ascending order of relative atomic mass. Element with similar chemical properties are placed into the same vertical column known as group. Left empty spaces for undiscovered element. And next one, Henry Moseley, you arrange element according to ascending order of proton number. He introduced the concept of proton number. So please remember, arrange the element according to ascending order of proton number. Alright, so what is mean by group? So group is known as vertical column of element in the predict table. What is mean by period? Period is known as horizontal row of element in the predict table. Alright, so please memorize all the chemical equation, balanced chemical equation of group 1 metal. Group 1 metal is known as alkali metal. Please remember, and this alkali metal, lithium, sodium, potassium, they will form ion with 1 positive charges. Alright, so we try to check the equation reaction with sodium react with water, potassium react with oxygen, and lithium react with chlorine. Try to do another example, potassium react with water. So how to do this one? So we take out the potassium ion, so we break the water molecule, hydrogen ion and hydroxide ion. During chemical reaction, this one join, so we will get potassium hydroxide. Please remember, potassium hydroxide is alkaline solution. When we see hydrogen ion single, so we make it hydrogen gas. How to balance the equation? So we put 2 in front of potassium hydroxide, then we balance potassium 2, potassium 2. Next we balance oxygen 2, oxygen 2. Alright, so next we check the hydrogen 4, hydrogen 2 plus 2, 4. Alright, try to practice next this one and this one. Alright, so group 17 element is known as halogen. And please remember, all these halogen exist as diatomic molecule. So when we writing the formula, we must write Cl2, Br2, I2. All these group 17 element can react with water, alkali and iron. And please remember, when a iron react with bromine, so what product we will take? Please take iron 3 ion. And we take bromide ion. Don't join during chemical reaction, join FeBr, take the 3, put here. Alright, so how to balance the equation? When we see 2 and 3, so 2 times 3, 6, 3 times 2, 6, iron 2, iron 2. Alright, so this is the example given, and please check when reaction with chlorine. Example of this reaction, chlorine react with sodium hydroxide. How to do this chemical equation? When chlorine, please put Cl2 react with sodium hydroxide. How to do this reaction? Please remember, this is alkaline solution, so we need to put 2 here. We take 1 sodium hydroxide, we take another sodium hydroxide. This one will ionize completely, produce sodium and hydroxide. This one ionization, partial ionization, will give us hydrogen and NaO. So we break Cl, we break the Cl. So hydrogen join with hydroxide, we will get water, H2O. Alright, so next we try to join sodium, join with chloride, we will get sodium chloride. So next, last one, we try to join this one here, so we will get sodium hypochlorous. Alright, so this is the equation that student must remember, so please practice and do more question. Try to check how to describe the position of element in the predict table. Try to look at the question. So state the position of element in the predict table, so we take the proton number 2.5. We try to do the electron arrangement 2.5. Alright, so this element has valence electron 5, therefore it will be from group 15. it will be from group 15. And it has two number 1 and 2, therefore it will be from period 2. Alright, so how to explain this, the position of element nitrogen in the periodic table. The element is nitrogen atom. The electron arrangement of nitrogen atom is 2.5. Nitrogen atom have 5 valence electron in the outermost shell, therefore it is in group 15. Alright, so next one, hydrogen atom has 2 shell occupied or filled with electrons. Alright, filled with electron, therefore it is in period 2. Alright, so try to check this question. The periodic table with the element that not represent the actual symbol is given. So please remember, this is group 1 element. Alright, this is group 1, this is group 2, group 3 until 12, this is 13, 17 and 18. Alright, so the element, so we check the first question, the element, which element exists as monoatomic gases, that will be element B. Which element exists as diatomic molecule, that will be element F. Alright, so state the position, so we try to check the position of element C. So element C, 1, 2, 3, 4, 5, 6. Alright, 6, 7, 8, 9, 10. Alright, 10 and we have 11. So the proton number 11, 2.8.1, it has valence electron of 1, therefore it from group 1. Alright, so it has total 1, 2, 3 numbers, so therefore it from period 3. Period 3. So the element shows 2.8.1 it from group 1 and period 3. Alright, which element, so we go for question number 4, which element chemically unreactive? Explain your answer. That will be element from group 18. So we choose the element from group 18. So here please remember, duplet, all these will be arrangement will be octet. So we choose element B. Element B as achieve stable octet electron arrangement, therefore it chemically unreactive. So now in the elements C and G, which element is chemically reactive? So please remember all group 1 elements. So we have Linac here. When going down the group 1, please remember the reactivity will increases. So which one is more reactive? G will be more reactive. Why G is more reactive? So we try to check. C, the atomic size is smaller. G, the atomic size is bigger, and the nucleus at the center and the valence electron at the outermost shell. So the nucleus at the center, the distance between nucleus and the valence shell is further apart, therefore the forces of attraction for element G will be weaker. Thus element G, if let's say this is 2.1, this is 2.8.1, element G has higher tendency to release one valence electron and achieve stable octet electron arrangement. So how to answer this question? Between element C and G, which element is more reactive? So element G is more reactive than element C. Atomic size of G is bigger than element C. The distance between nucleus and electron valence of G is further apart than C. Thus the attraction forces of nucleus of G towards its valence electron is weaker. Okay, and this causes what the element G has higher tendency to release or to donate its valence electron to achieve stable octet electron arrangement compared to element C. Therefore, G is chemically reactive. Alright, so which element can react with oxygen to form an M4 ferric oxide? Please remember M4 ferric oxide. M4 ferric oxide and oxide which can reacts with both acid and alkali solution. Alright, M4 ferric oxide will be aluminium oxide. Aluminium from group 13. Alright, so please check where is group 13. So this is group 13. So element X will be act as M4 ferric oxide. And try to check the next question. Question number 7. Arrange the element in the periodic table according to increasing order of atomic size. So how to arrange the element in the periodic table according to increasing order of atomic size? So we try to check which one is the smallest atom or element. B will be smallest, which one will be biggest? So G will be biggest. So we go this way, the second will be this one and become here. So the third one will be here, then this one bigger. So the element B is the smallest, then following A, F, E, D, X, C, H, and the last one will be G. Alright, so the answer is given here. Please do more revision. And alright, so we move on to the next part. State the 4 special characteristics of transition metal. Where is the position of transition metal from group 3 until group 12 is known as transition metal. These transition metal have a 4 special characteristics. They can show various number or oxidation number or different oxidation number. They can form colored ion or colored compound. They can form complex ion. Alright, they can form colored ion or colored compound. They can form complex ion. They can act as catalyst. Alright, so the answer is given here. All right, so next one, the catalyst. Name the catalyst used. Arbor process is a production of ammonia. Ammonia solution is used to make fertilizer. The name of the catalyst will be iron. Contact process is a production of sulfuric acid, is used to make fertilizer, paint, all that. Here the name of the catalyst will be vanadium 5 oxide. Oswald process is a production of nitric acid. The name of the catalyst will be platinum. And hydrogenation or production of margarine, the name of the catalyst will be nickel. All right, so we move on to the next question. All right, try to go for next question. Element C. Element C is here. All right, react with water. The symbol of water H2O to produce a colorless solution. We try to do the actual one when we take sodium from group 1. Element C from group 1. All right, sodium react with water. So sodium, it will form Na positive, water, hydrogen ion, hydroxide ion. During chemical reaction, sodium ion combined with hydroxide ion form alkaline solution. It will turn the red litmus paper into blue color, so indicate an alkaline solution is produced. Then when we see hydrogen ion single, so we make it hydrogen gas. All right, so how to balance this equation? We try to put 2 here, then balance sodium 2, sodium 2. Next we balance oxide 2, oxide will be 2. So hydrogen balance itself, so we have hydrogen 4, 2, 2, 4. All right, so we try to check how to do here. So I take C. So we take C, react with water, so we will get COH plus hydrogen gas. Balance 2 here, 2 here, 2 here. So state the observation: when red litmus paper is placed in the solution form, it will turn to blue color. All right, so element F. Where is the element F? Element F is given in group 17. Is placed in group 17. Reacted with iron wool. What is the formula of iron wool? Fe. So what is the symbol product we will get? We try to read the question. Write down the chemical equation when iron wool react with element F. So please remember all group 17 element. Group 17 element exists as diatomic molecule. Therefore, we take one example, chlorine, Cl2. When iron react with chlorine, all right, so we will get what product? Please take Fe3 positive. Then here Cl negative. So we will get FeCl3. All right, so FeCl3. How to balance this equation? So here 2, here 3. So how to balance 2 times 3, 6, 3 times 2, 6. So iron will be 2, iron will be 2. The name of the product form is iron 3 chloride, and the color of this product will be brown color. All right, and please remember we change this one into F. So the element given in the periodic table F, and this one we change it into F. So the answer given here. All right, so next calculation. So when 0.1 mole of iron will react with excess of element F gas, calculate the mass of the product form. So here the mass, how to find the mass? We try to write down the formula. Mass is N times with molar mass. All right, so when we have 0.1 mole of iron, we check calculate the mass of the product will be here. So how to calculate this one? We find the ratio mole. How to find the ratio of mole? So 1 mole from equation. We study the equation carefully. All right, so here 1 mole. So I put here 1 mole of Fe iron react and produce 2 mole of FeF3. All right, so then we take the answer given. 0.1 mole of Fe will give us what? 0.1 divide with this one times with this one. So we will find the ratio mole, which is 0.2 mole. 2 mole of FeF3. So we already score 1 mark here. Next point, we go for mass. Mass of FeF3. So we take number of mole times with molar mass. So the number of mole 0.2 times with molar mass of iron, RAM of iron given here 56 plus 3 times RAM of F is given here 35.5. So we try to find the answer 32.5 gram. Please look at this question. So we try to read this essay question. Diagram 7 below shows the standard representation of lithium and nitrogen atom. So we circle the proton number 3 and proton number 7. So lithium, the electron arrangement 2.1 and the nitrogen 2.5. Right, so we try to check the question. So based on the diagram, explain the position of lithium and nitrogen in the periodic table. So we try to explain the electron arrangement of lithium is 2.1 and the nitrogen atom is 2.5. Both lithium and nitrogen atom has 2 shells filled with electrons. So both lithium and nitrogen have 2 shells filled with electrons. Therefore, lithium and nitrogen belongs to period 2. The number of valence electron of lithium is 1. So if we check the number of valence electron 2.1, it has one valence electron, therefore it belongs to group 1. And the number of valence electron in nitrogen is 2.5. So when valence electron 5, it belongs to group 15. So nitrogen belongs to group 15. So we move on to the next question. Diagram below shows the apparatus setup for the reaction between sodium and chlorine gas. So this is the reaction between sodium plus chlorine. Please remember, chlorine, we must put Cl2. It exists as diatomic molecule. And the reaction between sodium and chloride will give us sodium chloride. So NaCl. So we take out the sodium ion, we take out the chloride ion. So during chemical reaction, the sodium ion combine with chloride ion to produce sodium chloride. A white color crystal will form. How to balance the equation? We check the sodium chloride 2. So I put 2 here, chloride 2, sodium 2, sodium 2. Questions. So explain the observation and write the balanced chemical equation and the mass of compound form. So this is the mass of sodium chloride form. All right, it's given 5.85. What is the mass of sodium? So first I try to do the table. So your observation, so sodium burn vigorously. So always remember, lithium will produce red color flame. All right, sodium when burned, it will produce yellow color flame. All right, so it will produce yellow color flame, and potassium, it will burn and produce lilac color flame. It will produce lilac color flame. All right, so here sodium burns vigorously with yellow color flame and produce white color crystal or powder. The chemical equation is given. And how to find the mass of sodium? So we try to check the figure given, the number given in the question, 5.85, and this is known as mass, the mass of sodium chloride, the product form. And we try to convert into number of mole. We take mass over molar mass. So first step will be mass, number of, we take the number of moles of sodium chloride. So we use the formula mass over molar mass. So we apply in the formula, so it will be 5.85 divide with sodium is 23 plus 35.5 will be RAM of chloride. So we will get 0.1 mole. All right, so now we try to compare. So we have sodium chloride, we check the equation, 2 mole, okay, produced from 2 mole of sodium. So we try to answer 2 mole of sodium. All right, 2 mole of sodium produce 2 mole of sodium chloride. So we check this one, we try to find the ratio mole. 0.1 mole of sodium will produce when these two value is same. So we take the 0.1, we put here 0.1 mole of sodium chloride. So now we need the number of mole of sodium to determine the mass of sodium used. So how to determine the mass of sodium? So we take the number of mole times with molar mass of sodium. So the number of mole 0.1 times with the molar mass of sodium is 23. So we will get 2.3 grams. So the answer is given here. So try to do more questions. We move on to the next part. Try to check the next question. This question is an experiment that can come out in section, right, section C. All right, we try to read the question. Study the following statement. The statement is given: metal X is more reactive than towards the water than metal Y. Please remember, alkali metal belongs to group 1. All right, group 1 metal, when we going down the group 1 metal, so we check group 1 metal, we have lithium, sodium, potassium. When going down the group 1, the reactivity increases. So we can take lithium, potassium, or we can take lithium and sodium. So in this case, I'll take sodium and potassium. All right, based on the above statement, suggest metal X. So I suggest metal, all right, the metal X, I suggest potassium, more reactive. All right, then I suggest the metal Y is sodium. All right, so we need to include example of metal X, metal Y, procedure to conduct this experiment, result and conclusion. So the standard answer will be here: metal X is potassium, metal Y is sodium. Procedure: we cut a sodium into small piece using a knife. We use the filter paper to absorb the paraffin oil that present on the surface of sodium. We drop the sodium carefully onto the surface of water that fill in the glass straw using forceps, and we record the observation. The solution that form, take the sodium, react with water, so we will get sodium hydroxide plus hydrogen gas. All right, how to balance the equation? I put 2 here, so sodium 2, sodium 2. I balance oxygen 2, oxygen 2. So hydrogen will be 2 to 4, so the hydrogen is balanced. All right, so and the solution that form is alkaline solution. And this alkaline solution, we use a red litmus paper to test. It will turn into blue color. All right, so we test the solution form by using red litmus paper. The step 1 until step 5. All right, we repeated the step 1 until step 5 using potassium to replace sodium. All right, next part we go for result. So the result we tabulate in the table form. We put the alkali metals that we investigate in this experiment, sodium and potassium, and here we can put observation or reactivity towards water. And the last part will be conclusion. So we go for conclusion. The conclusion will be potassium is more reactive towards water than sodium. All right, we move on to the next part. So under here, we try to check the question number 8. When group 1 metal react with water, bubbles of gas, colorless gas are evolved. And here we show 3 experiments. So here the bubbles is formed. So this bar here a lot of bubbles form. So therefore this is known as potassium. And here less gas bubbles is formed. So this will be lithium and this will be sodium. All right, so the red litmus paper turn into blue color. That means the product form alkaline solution is produced. All right, so which metal is most reactive? So we try the metal that most reactive is metal X. All right, and based on the answer, give the reason, because here we can see a lot of colorless gas bubbles is released. So more colorless gas bubbles are produced. And we try to check based on the diagram name the gas evolved. So when we take potassium react with water, so we will get potassium hydroxide plus hydrogen gas is released. So how to balance the equation? So we try to balance the here we put 2 here, potassium 2, potassium 2. Next we try to balance the oxygen 2. So we put 2, oxygen 2, hydrogen 4, hydrogen 2 plus 2 4. So the name of the gas release is hydrogen gas. All right, arrange the metal W, X and Y according to increase reactivity. So from less reactive to more reactive, the less reactive will be metal Y. All right, so next will be W and more reactive will be metal X. All right, write the formula of the product form when metal Y react with water. So the K we change it to Y. All right, so all the K we change it to the Y. So the formula of the product form is YOH, and we take the hydrogen we put here. All right, so uncheck question number F. Based on the diagram 5, the product formed from the reaction between metal W and water. So they want the product form. So between the metal W and water, that will be WOH. All right, and react with chlorine. The formula of chlorine Cl2. All right, we try to answer like this. So we take chlorine reacted with sodium hydroxide. I represent this one with sodium hydroxide, and what product we will get, we put 2 here. So we take out the sodium hydroxide NaOH, we have another NaOH. This one will ionize Na, and we will get OH. This one NaO, then we will get H. We take the H. The chloride will break, produce chloride atom. So during chemical reaction, H join with OH. So we will get H2O. Alright, so we erase the hydrogen and hydroxide. The sodium and chloride combined will give sodium chloride. So we erase this one. The sodium will combine with NaO. We will get sodium hypochlorous. All right, so now the chloride we change with W. All right, so the sodium we change with W. So this one will be W. The sodium we take, we change with W. The sodium we take, we change with W. So this is the answer that students should write. The answer is given here. All right, so we move on to the next part. All right, under this one, under chapter 5, chemical bonding, please remember the most important chemical bonding is known as ionic bonding. The formation of ionic bonding occur between metal plus non-metal, and via transfer of valence electron between metal to non-metal. And the physical properties of ionic compound, please remember it has high melting and boiling point due to the stronger electrostatic forces of attraction occur between the metal ion and non-metal ion. More heat energy is required to overcome the forces of attraction. And next one, the ionic compound, all the ionic compound in solid state. Okay, solid state cannot conduct electricity because the ions are unable to move freely to conduct electricity. But in molten or aqueous state, the ion able to conduct electricity. And next one, all ionic compound soluble in water but insoluble in organic solvent. So please remember this point. Next one, we go for covalent compound. Covalent compound is made up of between non-metal plus non-metal element, and we are sharing of valence electron between the non-metal element. And their physical properties, they have low melting point and boiling point due to the weaker intermolecular forces of attraction or van der Waals forces of attraction between the molecule. Thus less heat energy is required to overcome the forces of attraction, and they exist as a neutral molecule. Therefore, all covalent compounds do not conduct electricity except acid, because acid can ionize in water, produce hydrogen ion. All right, so next we go for all covalent compound insoluble in water but soluble in organic solvent except halogen. Halogen, acid, and one more, ammonia. All right, these three solvent can dissolve in water, solvent can dissolve in water, all right, and also in organic solvent. All right, so we move on to the next one. Sodium chloride. Sodium chloride, metal plus non-metal, they exist as ion in molten or aqueous state. All right, the ions able to move freely and conduct electricity. So this made up of ionic compound. So metal plus non-metal. All right, so how to answer this question? Explain why sodium chloride can conduct electricity in aqueous state but cannot in conduct electricity in solid state. Sodium chloride is an ionic compound. In solid state, the sodium ion and chloride ion are held together by stronger electrostatic forces of attraction in lattice structure. Alright, so next point, the ions are fixed in at the position and do not move freely. Hence, ionic compound in solid state do not conduct electricity. In aqueous or molten, the ions are able to move freely, therefore the compound can conduct electricity. Alright, look at this question. Explain why molten lead to bromide. The formula of lead to bromide, PbBr2. Alright, so it's made up of lead to ion and also bromide ion. In the molten state, the ions able to move freely, and this is made up of ionic compound. And naphthalene C10H8 is made up between non-metal plus non-metal. They exist as neutral molecules, and the type of bonding will be covalent bond. Therefore, molten naphthalene do not conduct electricity. There is no deflection of ammeter needle. But here when we use molten lead to bromide, there is a deflection of ammeter needle. All right, explain why. So we check that. Explain why molten lead to bromide conduct electricity while molten naphthalene does not conduct electricity. So first point, lead to bromide are made up of ionic compound and exist as ion in molten state. Alright, so we go for in molten state, the lead to ion and bromide ion are able to move freely and conduct electricity. However, naphthalene is an ion covalent compound and made up of covalent molecule or neutral molecule. In molten state, there is no freely moving ions to conduct electricity. Thus, naphthalene do not conduct electricity in solid or in liquid state. Alright, so we're trying to go for next question, essay question, the formation of ionic bonding. The formation of ionic bonding occur between metal, alright, metal plus non-metal. So how they occur via transferring of valence electron. Alright, we try to check the formula. So I take the sodium, so write down the electron arrangement 2.8.1. When valence electron 1, alright, this will be metal, sodium will be metal. Alright, so we check for the oxide, we take the proton number 2.6. When valence electron 6, this is known as non-metal. So oxide is known as non-metal. So the type of bonding form is ionic bonding. And we try to check the formula, metal will form cation. So we take sodium, we take this one, sodium ion. So the electron arrangement 2.8, and sodium ion has achieved stable octet electron arrangement. And we check for the oxide ion, oxide non-metal will form n ion, so we put negative. So we check the valence electron 6. It need 2 more electron to achieve octet. Octet means the outermost shell contain 8 electron. We take the 2, we put in front of the negative charges. So in front of the negative charges, when oxide ion is formed, the electron arrangement 2 point, we take all these, we add here 2.8. So oxide ion has achieved stable octet electron arrangement, and we try to get the formula. So sodium oxide, and we take the 2, we put into the sodium atom. Alright, so and the formula, through this formula, we have 2 sodium ion. So we have 2 sodium ion. Alright, so please check 2 sodium ion and 1 oxide ion, and the electron arrangement of sodium ion 2.8 and oxide ion is 2.8. Alright, how to answer this question? So how to answer the question? We check the answer question. Explain the formation of ionic bonding between sodium atom and oxide atom. Sodium atom has electron arrangement of 2.8.1. Alright, this sodium atom will donate 1 valence electron. to achieve stable octet electron arrangement. Thus, sodium ion, a positive ion of sodium ion is formed. All right, now we try to talk about discuss about oxide atom. Oxide atom has electron arrangement of 2.6. The oxide atom it has valence electron of 6. It will receive 2 electron from 2 sodium atom. So how to answer this one? It will receive 2 electron from 2 sodium atom to achieve stable octet electron arrangement. Alright, a negative ion of O2 negative is formed when the sodium ion and oxide ion are attracted together by stronger electrostatic forces of attraction form ionic bonding. Thus, an ionic compound with the formula of Na2 is formed. So how to draw this one? So we have 2 sodium ions. So we put 2 sodium ion. We take the 2, we put here. So we open bracket, we close the bracket, we take the charge, we put here. And we check sodium atom as 2 shell. Alright, 2 shell, and we use our symbol dot here, 2.8. Alright, 2.8. And we try to draw for oxide. Oxide, it has 2 shells, so I put the symbol of oxygen atom. It has 2 shell. The charge will be 2 negative, so I'll put the 2 negative here. So we use different symbol here, 2. Alright, it has 6. The valence electron initially got 6. It received 2 electron. Please check here. So it has 6 valence electron. It received 2 electrons. So this is the answer we should draw. So we move on to the next part. Alright, now I try to discuss the formation of covalent compound. The covalent compound occur between non-metal plus non-metal. Alright, we are sharing of valence electron. Alright, so here the type of bonding will form covalent compound. Please remember, okay, few example of non-metal: carbon, hydrogen, oxygen, nitrogen, sulfur, and chloride atom. So when we have carbon dioxide, non-metal covalent compound. When we have water, non-metal covalent compound. Nitrogen dioxide, covalent compound. Ammonia molecule, covalent compound. Sulfur dioxide, covalent compound. Okay, how they form the chemical bonding via sharing valence electron, and we try to check the formula. So carbon, we take the proton number, we do the electron arrangement 2.4, and we check the chloride. It has proton number 17, 2.8.7. We try to ask question, how many electron needed to achieve octet. So carbon got 4 valence electron. It need 4 more electron to achieve octet. Chloride has 7 valence electron. It need 1 more electron to achieve octet, and we do crossing. Bring the 4 here, 1 here. The formula will be CCl4. Alright, so we try to check how to answer the essay question, the formation of covalent bond between carbon atom and hydrogen atom. Try to just check the formula. So in this formula, we need 1 carbon atom and we need 4 chloride atom. So I'll try to discuss carbon atom. Carbon atom with electron arrangement 2.4 need 4 more electrons, okay, to achieve stable octet electron arrangement. Now we try to discuss about chloride atom. Chloride atom with the electron arrangement 2.8.7, it need 1 more electron to achieve stable octet electron arrangement. So 1 carbon atom will contribute 4 valence electron. Okay, to how many chloride atom? To 4 chloride atoms. So 1 carbon atom will contribute 4 valence electron to 4 chloride atom, and 4 chloride atom will contribute how many valence electron? 1 valence electron each to 1 carbon atom. Alright, so they will form covalent bonding. So next point, 1 carbon atom. So we go for 1 carbon atom and 4 chloride atom shares how many pairs of valence electron? Please check here, 1 pair, 2 pair, 3 pair, 4 pair. 4 pairs of valence electron and form 4 single covalent bond. So here all carbon atom and chloride atom has achieved stable octet electron arrangement. A compound with the formula, a covalent compound with the formula of CCl4 is formed. Alright, so we try to check how to draw the electron arrangement. So I check here CCl4. Alright, so we have CCl4. Please circle this one. Alright, please circle this one. So we need to put inside sharing valence shell between chloride and carbon atom, and outside of chloride atom we try to put, we take the 7 minus 1, so 7 minus 1 we need to put 6. Alright, how to draw this one? So I take here carbon first shell, second shell. Alright, so first shell carbon got 2 electron. The valence shell carbon already contribute all electron for sharing. Alright, so valence electron, leave it empty. We check the formula CCl4. We need 4 chloride atoms. So 1 chloride atom, first shell, second shell, the valence shell. Alright, so we have another chloride atom, first shell, second shell, and the valence shell. We have another chloride atom, first shell, second shell, and the valence shell. So we have fourth chloride atom, first shell, second shell, and valence shell. So we try to fill up the first shell and second shell of chloride atom. The first shell got 2, second shell got 8. Alright, 2, 8. 2, 8. Alright, 2, 8. Alright, we already fill up our first shell and second shell of chloride atom. Now we try to go this chloride atom inside the sharing shell of valence electron. We need to put 1 atom. So inside here I put 1 for each chloride atom. So here inside we put 1, here inside we put 1, inside we put 1, and we check outside of valence shell. We need to put 7 minus 1, so we need to put 6. Outside of chloride valence shell we put 1, 2, 3, 4, 5, 6, 7 minus 1, it will be 6. So here 1, 2, 3, 4, 5, 6. Alright, so here will be 1, 2, 3, 4, 5, 6. So here will be 1, 2, 3, 4, 5, 6. Alright, now please remember when chloride contribute 1 electron for sharing, carbon also will contribute 1 electron for sharing. Alright, so here carbon will contribute 1 electron for sharing, carbon will contribute 1 electron for sharing, carbon will contribute 1 electron for sharing. So please remember 1 carbon atom and 4 chloride atom. Chloride atoms they share how many pairs? 1, 2, 3, 4. They share 4 pairs of valence electron. Alright, and they form 4 single covalent bond. So this is the point I described here. 1 carbon atom and 4 chloride atoms shares 4 pairs of valence electron form 4 single covalent bond. To check question number 7, the diagram shows the electron arrangement of compound T2O. The element T react with oxygen to produce T2O. Alright, so the formula is given. So element T as proton number of 1, so oxide as the proton number of 6. Alright, so the type of bonding form. So element T is most likely hydrogen non-metal, oxygen is non-metal, so the type of bonding form is covalent bond. The electron arrangement of atom T, so we take electron arrangement of atom T, so it has only 1 valence electron, 1. Alright, so state 2 physical properties of this compound form. They have low melting and boiling point, do not conduct electricity in any physical state. Alright, now we go for question number 3. Explain the formation of chemical bonding by referring to the diagram shown. Alright, so we have the T atom, it has only 1 electron in the shell. So we have oxide atom, it has first shell, second shell, it has 2 electron at the first shell. Alright, and it has 6 electron in the valence shell. Alright, so first point we go for atom T as electron arrangement of 1 and need one more electron to achieve stable nuclear electron arrangement. Oxide atom as electron arrangement, the electron arrangement will be 2.6, this will be 1. Alright, so oxide atom as electron arrangement 2.6 and it need 2 electron to achieve stable octet electron arrangement. So one oxide atom, so we have one oxide atom will contribute how many electron for sharing? Alright, so one oxide atom will contribute 2 valence electron to T atom, atom T. 2 atom of T will contribute 1 valence electron each to oxide atom. So 1 oxide atom. So we check here the formula, 1 oxide atom and 2 T atoms of T, they will share a pair and 2 pairs. 2 pairs of valence electron form 2 single covalent bond. Alright, so a covalent compound with the formula of T2O is formed. Alright, what is the purpose of formation of chemical bonding? The purpose of formation of chemical bonding to achieve the stability of electron arrangement can be achieved by transferring or sharing the valence electron, or another one we can use the T achieve stable duplet electron arrangement, and oxide achieve stable octet electron arrangement to achieve stable electron arrangement. All right, state the example of triple covalent bond. Triple covalent bond can be formed between the nitrogen atoms in the nitrogen molecule. And all right, please remember an example of double covalent bond. Double covalent bond present in oxygen molecule and also in carbon dioxide molecule. All right, try to check another question. Diagram below shows the formation of dative bonding between hydrogen ions. So we need to remember what is meant by dative bonding. Dative bonding is a special, all right, special type of covalent bond where the sharing pair of electrons comes from only one atom. So in this case we have water molecule. This is H2O. This water molecule is made up of covalent bond between hydrogen atom and oxide atom. And please check, this high oxide atom is known as highly electronegative atom, and this oxide atom also contains two lone pair of electron which can be shared to the hydrogen ion. And please check, the hydrogen atom, it has valence electron or one electron when it form hydrogen ion. This hydrogen ion do not have electron in the shell, and it need two electron to achieve stable duplet electron arrangement. Therefore, one of the lone pair of the hydroxide atom from water molecule will be shared to the hydrogen ion through formation of dative bonding. All right, so we try to check the answer question. What is meant by dative bonding? Dative bonding is a special type of covalent bond where the electron pair that is shares come from only one atom. Another example of dative bonding, please remember ammonium ion. So please remember dative bonding. Two example. Number one is known as hydroxonium ion, formula H3 or O positive. Another one is known as ammonium ion, NH4 positive. All right, so here next question is, hydroxonium ion reach a stable electron arrangement or not? So answer yes. Why? Because it's reach stable octet and duplet electron arrangement, where we can check from here hydrogen achieves stable duplet electron arrangement. At the same time, oxygen achieves stable octet electron arrangement in the formation of hydroxonium ion. All right, so now we try to explain. Next question will be explain the formation of dative bonding in hydroxonium ion. So the oxide atom in hydroxonium or in water molecule, the oxide atom in water molecule contains two lone pairs of electron which are not involved in the formation of covalent bond between oxide atom and hydrogen atoms. All right, so next we try to discuss about this one. This is known as hydrogen ion. Please, hydrogen ion do not have electron in the shell, and it need two more electron to achieve stable duplet electron arrangement. So how to answer hydrogen ion that does not have any electron in the shell? So one of the lone pair of oxide atom in water molecule will be shared to the hydrogen ion, so that the hydrogen ion will achieve stable duplet electron arrangement. So the third point, the lone pair of electron of oxide atom in water molecule will be shared to hydrogen ion via formation of dative bonding. So this ion is known as hydroxonium ion. Thus hydroxonium ion is formed. In hydroxonium ion, oxide atom and all the hydrogen atom have achieved stable octet and duplet electron arrangement respectively. All right, now we try to check the next question. Diagram below shows a teller counting banknote. So turning the banknote, he wets the finger with water. All right, so please remember the paper or the banknote is made up of cellulose. All right, it's made up of cellulose. Cellulose contains carbon, hydrogen, and oxygen. So please check oxygen. This oxygen is known as highly electronegative atom. It has higher tendency to accept electrons. Some of this oxygen atom also contains lone pairs of electron. All right, so we try to check when the wet finger, again, it has water. All right, so in water we have oxide atom. This oxide atom is highly electronegative atom. All right, so what will happen? The sharing pair of electron will be pulled towards the oxide atom. Thus, this causes the oxide atom become partial negative charges. The hydrogen atom become partial positive charges. So we will represent with this symbol. Thus, the water molecule become dipole. All right, and here we have cellulose in the banknote. Also, we contain oxide atom. This is partial negative. So there is a attraction forces between the hydrogen ion from the water molecule with the cellulose oxide atom of cellulose molecule, and this will causes the formation of hydrogen bonding. All right, so how to answer this question? Okay, state the concept used here. The concept is the formation of hydrogen bonding. Explain why the wet finger need to be wet with water. All right, so the banknote will stick to the wet finger due to the presence of water molecule. All right, the water molecule forms hydrogen bonding between the cellulose fiber in banknotes and the water molecule on the fingertips. Dry banknote is hard to flip because only weak van der Waals forces of attraction exist between the banknotes and the dry finger. All right, so we move on to the next question. All right, next we move on to the formation of metallic bonding. This metallic formation of metallic bonding occur between the cation of metal and the sea of electron that form, okay, when the valence electron is delocalized. The type of attraction forces exist between the cation of metal and the sea of electron is known as electrostatic forces of attraction. All right, electrostatic forces of attraction. We try to check the question. Diagram below shows a mini project produced by a group of students. Electrical wire are made from the metal, can conduct electricity. Explain what is meant by delocalized electron. This delocalized electron is the electron that move freely and not owned by any atom nor ion. They able to move freely within the metal structure. All right, so and this sea of electron is formed when the valence shell of metal atom overlap, resulting in electron delocalization. All right, so we try to check this diagram. So here, all right, please check this structure. So this is known as metal. The metal are arranged, the atoms in the metal are arranged closely packed and in order, and this is known as valence electron of metal atom. All right, this metal can vibrate and rotate, okay, in at fixed position, and during vibration and rotation, some of the valence electron can be delocalized, okay, can be donated and delocalized. All right, so and this delocalized electron, okay, can form a sea of electron when the valence shell of electron metal atoms overlap. All right, so we try to answer this question. Why the metal can conduct electricity? Give evidence for your reason. So the metal atom are arranged closely packed and in order in solid state. All right, so what will happen? During the metal can only vibrate and rotate at the fixed position, and the valence electron of atom can be donated easily and delocalized, although in the solid state. The metal ion that are positively charged are formed, and the valence electrons are delocalized. All delocalized valence electron can move freely between the metal structure and form sea of electron. The electrostatic forces of attraction between the sea of electron and positively charged metal ion form a metallic bonding. And how to draw this one? So we try to draw the label the metallic bonding. So we label this one is known as valence electron. All right, and this is known as cation. All right, and this is known as sea of electron. All right, so that's all from me. So I wish you good luck. Thank you very much. Take care. See you in next slot.